Okay. Says I'm live now, and there we go. Cool. So I'll take that off of there. All right, chat. I am getting started. So, we've got the YouTube chat. We're doing YouTube here instead of the usual, or I guess what I'm used to is the click meeting. So this is going to be a little different. So you just got to let me know what's happening, if anything's going wrong, and we'll take it from there. So welcome to this webinar on data structures. We're a little late, so we'll kind of go through and make sure that we get everything in this hour. So thank you for being here. We had a lovely time chatting about a few things. And now let's jump into data structures proper. So data structures, some of you actually saw someone like, what is a data structure? And that's kind of what we want to talk about first. So for those of you who already know what a data structure is, hopefully this can be a good review, or maybe you'll learn a few things as well. This webinar is actually a little interesting as the focus of data structures is not just in GameMaker. Like using sequences and making games like that, a lot of that is structured around GameMaker engine specifically, whereas data structures is a software algorithm. Like it's something that you create and you can use it anywhere in any language, and it's used all over the place. This is not GameMaker only. Now, there are a few things in GameMaker, like maps, that they're called maps in GameMaker, which is a little different. But when you move on to, or if you do anything else, web development, mobile development, you use any other engine, just general software development, you're going to be using data structures in there. And that's because data structures is just a way to organize data with some rules inside of it. Now, a quick caveat here is GameMaker has been doing a ton of work with arrays and structs over the last year and a half, 2 years. And they actually have a note right here that says you should actually use arrays and structs over things like DS lists and maps. And that's because the arrays are a little bit easier to use, and they're actually garbage collected. Now, in general, you might not know much about garbage collection as GameMaker does it all for you. So garbage collection means that when you create something, you then have to destroy it and release that memory. So arrays and structs are garbage collected, where data structures are not. You can actually cause a memory leak, which will eventually crash your game if you just create data structures. So we're going to take a look at how to create them, but then also how to release them properly. So for some things, arrays and structs, definitely the way to go. But there are some things that you definitely still want data structures for. Now, grids right here is a little bit different than MP grids, but they use kind of the same thing. So MP grid is for motion planning, and it's how you actually get AIs to move around and be able to navigate your room using logic inside of there. And that uses a lot of the same information that you get from a grid. So knowing how to use a grid then lends itself to using an MP grid, which means that you can do AI navigation. And each one of these, and way more data structures, are available in lots of languages, and you can actually create them yourself inside of GameMaker if you ever had a purpose for. So something like a list here, yeah, you probably want to use an array, especially with all the really nice array functionality coming to it, but we're still going to tackle it because the idea of a list is still important. And they have all of these functions already created for you, which is pretty nice. We're also going to tackle maps. And although they recommend using structs here, you can actually use maps to do saving and loading, in my opinion, in a very quick and easy way. You can do saving and loading in structs. It's a little more complex, but maps actually have a lot of functions specifically for saving and loading, and you can work with JSON, and you can add other data structures inside of maps. So there's a whole lot of information there to be used. So what we're gonna do, I will show you the project that we're going to create. So this is the goal for the webinar, is I have a project right here. So I coded this in GameMaker, and we're gonna code this together, and it's a visualization of what you can do with data structures. And we're gonna be focusing primarily on the functions of data structures, but using things like a grid, you can create a construct where you can drag and drop values inside of there. You can grow and you can shrink a grid. You can select a value and then you can set all the values around it, and this size can change, and you can do this anywhere you want. You can shuffle up the values of a grid, you can sort it, you can create it and destroy it. These are all functions that are already built in, and we don't have to do a lot of work inside of there. Then we also have the priority queue, which is a little bit different. So why don't we start with a queue here, where you can see there's 10 slots inside of here, and if we want to see the head, we can, and if we want to see the tail, we can, but we can't actually see anything else in between it unless we start dequeuing the information inside of there, which is pretty interesting. Our priority queue is very similar to that, except if we add some values inside of here, we can still only see the first and last, but then we could actually come in here and we could change the value of an item, and everything inside of there changes based on the priority of that item. So that's pretty cool too. We got stacks, which is pretty similar to lists and queues, but maps I think is the most interesting. So a map is really useful, but it has a few caveats because when you add something to it, you don't actually know where it's going to be. So when we add values in, I've visualized this by making the values all over the place because it's not necessarily random, there is math behind it, but when you want to know a value, you can't just go to the 5th index and access the 5th thing you added in there. You have no idea. The very first thing here is 315, and the last is 100. And we don't know which one is which or how they get added in and sorted, and that's kind of what a map is. So a data structure is a way of organizing data, and it has its own rules. And if you follow those rules, you can recreate that data structure with any struct you want, but you also, it can take a little while. So what I'm going to do is we're going to go through each of these and we are going to code them inside of this project. So we're going to focus just primarily on the actual coding of the functions. I'm going to try to ignore things where we draw things. I've already got a lot of that set up. So we're going to start with the list here. So I'm going to show you kind of what we're doing. So here is the room for lists. And what down here is the ability to change each room because we're going to have lots of rooms. And these are the buttons that actually do something. Now, each of these will draw its own text. It's a list button right here. And so it has a variable called myText and myList. And it's going to draw the information that it has from myText. And then when we press it, it's going to actually execute that function. And this is where we're going to spend the majority of the time actually coding in the functions that are already available for each of these data structures. And that's kind of the goal here. This project we'll put out there. It'll be available to download, so you can definitely check it out. I think it's really cool. I'm pretty happy with how it turned out. So, check that out and let's go ahead and get started. And we'll take breaks in between, and if you have any questions, throw them out in the chat, and I'll get to them as best I can. So, first thing, we have the obj list. Now, creating a data structure is almost like creating any other variable. We need to give it a name. So when we create it, it's a variable just like anything else, so we can give it any name that we want. I'm going to call this one myList. But we have to use a function to create this. So in this case, DS stands for data structure, list create. This doesn't take any arguments, it just creates a new blank list for us. And that's everything that we actually have to do inside of there. Now I also have this cleanup event, and this is where you traditionally clean up data structures. So the cleanup event will actually run when we change rooms, so we don't have to have a event in a new room destroying old data structures, because as soon as we change rooms, because this object is not persistent, it's actually going to take care of itself. And this is pretty much the same thing as ds list destroy, and we pass in myList. And then we have this draw section, and all this is doing is making sure the list isn't empty, and then it's iterating through the list, and it's drawing the values inside of it. It's drawing a square to represent the list, and then it's drawing the value inside of that list. We're not going to code that by hand. It's a big waste of time, I think. But all of this will be available if you ever need to visualize a list, a grid, or anything like that. You can grab this code and you can use it for whatever you want. So the primary part of where we're living is right here. This left pressed in the list button. So the way this works is I've got text, and I've given each one of these the text that it has. So it has add, it has different functions inside of it. So we're just going to check to see if this specific instance has this text, and if it does, when we click on it, we'll run that specific function. So let me show you what I mean. So we would say something like if my text is equal to add. And then inside of here, we would call the add function. Now, before we do this, and I'll go ahead and blow this up a little bit so you can see it better. One thing that is unique to data structures is that because you can create and destroy them, the actual variable doesn't go away. Like my list is a variable that is always going to be there, but it might be referencing something empty. And in this case, we want to make sure that we don't reference anything that doesn't exist. So there's a special function called dsExists. And this can be used for any data structure. And you pass in the ID, which in this case is the name of my variable, so my list, and then you tell it what type you think it should be, ds type list. So if it does exist, then we can do all of these things, because we're actually going to have the ability to create and destroy these lists on the fly, because that's what you can do with data structures. So here's the very first one. Now, for screen cap, for screen size reasons, we can only have the list so large. So I'm going to also make sure that the size of my list, so using the function dsListSize gets us the size. And we're going to make sure that it's less than 10 altogether. So it has to exist. If this button says add, and the size of the list is less than 10, then here's the function where you add it. You can say dsListAdd, and you call my list, and I'm just going to pass in a random number in this case so that it doesn't really matter. So it puts in a random number, and there we go. If it's not the right size, then we're just going to show a debug message, can't add more. Now, some of you may already know that this function, you can actually use lists and actually every other data structure. You can actually use, let me bring it back up. Every single one has a way of accessing it with an expression and an accessor. So the accessor for list looks like it's the pipe. Right above enter, you hold shift, press that, and then you can access it just like an array. So in that case, they're actually almost identical, but every data structure has an accessor, and you can chain accessors together, which is pretty cool. So if you have a list inside of a map or a list inside of a list, whatever, you can have multiples of these chained together, which is pretty handy. Now, I'm not going to use the accessors in this, as I think it's just one extra thing to look at, and it really does make it a lot different. I know the first time that I was looking at a $sign and a hashtag or a pound symbol inside of someone's code, it really confused me. I had to stop and think like, what is happening here? So I don't want that to be a barrier to understanding and being able to watch this. So we're not going to use accessors, but know that they exist because they are pretty helpful. So we're back to here. Let's go ahead and try this so you can see it. So this says add, this one says delete, sort, shuffle, destroy, and create. Now, we already have a DS list. We created it. We went through that code. Right now, there's just nothing inside. But if I add one, it adds a random number, and there we go. So that's the ability to add. The function itself is dsListAdd, and notice that this data structure, a list, we don't specify where it goes. An array, you can put any entry pretty much anywhere you want, and it doesn't matter. But this one, when you add, what you're actually doing is you're appending onto it. That means that you have to, that's how the data structure works here. So a list starts at 1 or 0, depending on how you want to look at it. The first entry is here, and when you add something, it always goes on to the next one. And that's what a list is. And when we delete it, we're also going to delete from the max size of it. So to show you that, let's go here and let's type else if my text is equal to delete, and we need to figure out the spot here. So I'm just going to create 2 lines here. I'm going to create a temporary variable called spot, and here we actually do choose, so I was wrong. So when we delete something, we actually can delete it from anywhere we want. In this case, I want to delete it from the very end. So we're going to say ds, we're going to get the size of our list one more time. And then we're going to use that in the function ds_list delete. My list and the spot we want. I could have put this whole thing inside of here, but just for clarity's sake, hopefully that makes a little bit of sense. Now, I'm not going to run this every single time we code each of these buttons, but I just want to show you this. So when we press delete, it's now going and it's deleting the top one. So as a list, that's kind of how this works. So every data structure has its own set of rules. And if you don't follow those rules, then it's not actually that data structure. Because the thing is, you can create all of this with arrays and such, but if you don't follow the rules, then it's not actually the data structure. It's something else that you have created. So when you talk to someone else and you say, oh, I'm using a map or a dictionary to do this, to sort this information or to hold it, then you have to follow those rules of a map. And if you don't, then it's not a map. It's your data structure, which is fine if it's working for you, but you can't have a conversation with another developer and say you're using a grid if you're not actually using a grid properly. So keep that in mind. So we're going to be obeying these rules and using these functions inside of here. So let's go ahead and code out the rest of a list. So we have else if, and I'm just going to copy this because that's the beginning of every single one. So we have sort, we have shuffle, and we've got destroy. So if we're going to sort, the function is ds_list sort. We give it the ID, and then we can choose whether it is ascending or descending. So in this case, I'll just put true. You have to put one or the other. Shuffle, again, same kind of thing. ds_list shuffle, and there's no shuffling algorithm that you can choose from. It's just, it shuffles. So there you go. Then destroy, we're actually going to instance destroy our list. And this is because we could use the ds_list destroy. I just coded it differently. So when we destroy the object, it actually destroys the list as well. We already saw that in the cleanup event. So if we want to destroy the list, we'll do that. And then at the very end here, what we'll actually do is add an else, because remember, this one checks to see if it's alive. So if it's not alive and we click a button, then we want to say if my text is equal to create, then we're going to create a new one. And to create a new one, we're actually going to create that object again. So I'm going to create it on the instances layer called obj list. So this is destroying the object, this is creating the object, and both ways are actually destroying the data structure as well. So let's try it out. And hopefully everything just works. So when we add something, we already know these two work. So let's go and sort them. Perfect. If we add more and sort again, we can shuffle. Excellent. And every time you shuffle, it changes it up. Sort, obviously it only sorts it once the right way. If we destroy this, it's gone. We can't add, delete, sort, or shuffle. If we create, It's now back, but we have to add some more before we can do anything. So that is DS lists in a nutshell. Add, delete, sort, shuffle, and then you can destroy and create it at will. So they're useful, but even GameMaker suggests you probably want to use arrays at this point, because arrays will give you a lot more functionality because you can just add more functionality yourself. And they're garbage collected or automatically, which is very nice. The cleaning it up yourself, not a big deal, but it does add a layer of complexity and possibility for your game to crash, which isn't super ideal. Okay, let's take a look at the chat and see if anyone has any questions. So I'm going through pretty quickly here, but I think everything's going fine. And if you have any questions, put them out. It looks like we've got a little bit of moderation there, so you just got to tell me if you have any questions. Otherwise, I'm just going to keep on going. Delete should make sure there's an entry. So you're probably right there. Yeah, if it's empty, what happens? Well, it doesn't look like it. GameMaker, the DS function looks like it might already check that itself, as it's not throwing any sort of error. So you can call DS list delete, and if there's nothing there, nothing happens. So it's probably a good idea to check that, especially if you were going to create this yourself, but it looks like it's already checked by GameMaker. So that's all good. Okay, let's go ahead and move on to the next one then. So let's take a look at grids. Now, there's a lot of code that I have inside of the drawing portion here, so we're not going to go over this at all. It's useless. Well, the code does stuff, but I want to focus on how to actually use this. So in the create event, we create a grid. It's called DS grid create. This one is a little different because when you create it, you have to give it a width and a height. A grid is just a two-dimensional array. So you've got a big box. It's a grid. Like, that's actually what it is. When we say DS map or priority queue, those things are kind of more abstract terms, but a grid is literally just a grid. So when you create it, you have to give it a size. We're going to start with 10 by 10. This goes through that grid, and it just fills it up with random numbers so that we can see that. Now, these are all variables that I've got to be able to actually drag the values inside of a grid around. Kind of a cool functionality. It's not built in natively, but we're going to have it in this one because we've already got it all right here. Then in cleanup, we destroy it. DS grid destroy. Every function for DS is DS, that data structure name, and then what it does. So the bulk of our time will be right here in the DS grid button. These ones are drawing some information, just some text on those buttons that we've already seen before. So let's go ahead and add a mouse left press, and we're going to execute functions. So in here, there's a lot of different functions we can do. So I'm going to start it right here. Again, we want to check that it exists. So if DS exists, that's one function that's unique in that you can check any data structure with this one function. But we are checking the grid here specifically. So if the DS grid exists, and if my text is equal to sort. So that's the first one we're going to do, is we've got sort. The order that we're doing these in doesn't matter at all. It's just a button you press, whether that button's at the top or bottom, just what it is. So we've got sort, and here's the function for that. DS grid sort. I bet none of you saw that one coming. And you just pass in the grid itself, the column that you're actually going to sort, and then whether it's ascending, which we'll do for true. Now, here I don't actually have a column set up right now, so we're going to go and by default, I'm just going to set column equal to 0. So that way, every time we do this, We can change the column right here if we want. In the actual finished project, I have it all set up so you can press 1 through 9 or 0 through 9 to actually do that. But that's adding a lot more unnecessary code in my opinion. So we're just going to ignore that. So this Feather doesn't seem to like it when you put one in there that doesn't exist and then you create it. So you have to do that. Probably would have fixed itself when I compiled it though. Okay, so we've got that. Now, if we run this, I think we can actually see this in action already. So if we go to grids, yeah, cool. So the list itself, you can't see anything when you start. You have to actually add the functionality there. But on grids, we've already got a grid set up. And all of the dragging and dropping, that was functionality that is in that draw event. So that's not using these functions. But if you wanted to do that, this is a great way to do some kind of inventory or maybe like a puzzle game or something. Who knows? But let's try sort. So we're on column 0. So if we sort that, 0, 1, and there we go. And you'll notice that it kind of sorts other stuff as well. It doesn't just target this one column. It actually affects the rest of them too. It doesn't sort them, but it does change up the entire row when it's sorting them. So you keep that in mind when you're doing the sort. Okay, let's go through and power out the rest of these. So let's say else if my text is equal to, and I'm not sure if I still have that copied, so I'll copy that. So we did sort. Let's do shuffle next. And this one is dsgrid shuffle. And all we pass in here is just my grid. Because again, it's just shuffling. It doesn't matter how it's doing it. We can't control how it shuffles or where it shuffles. It just does it. We also have clear, which this one is different than destroy. It actually sets everything to a value. So in here, if we try to clear a grid that doesn't exist, or that I have an error check in my original project, and leaving it out is probably a bad idea. Let's see what happens. The function for this is dsgrid clear. So again, my grid, that's the name of it, and we'll set them all to -1 so we can visually see this. And I'm just going to run this right now because I feel like I'm going to get an error if I click clear. If I destroy this, we'll find out as we go. But I'm calling it now. When you copy from a project, you should copy everything, even if it doesn't make sense. And I'm not doing that, so I'm kind of a hypocrite. But let's go on. Else if my text is equal to destroy. So here, we want to say instance destroy, and we're going to do the same thing we did before where it's obj grid. We're just destroying that like that. So takes care of it. Next, this one's pretty interesting. This is grow. So this one actually grows your DS grid by a column. And what I need to do in here is a little more code. Well, I've got a size restriction on this as well, but we're not going to worry about that. That's too much extra coding. You saw how we did it in a list. You just check the size of it. So there is a DS grid width and a DS grid height. So you can check both of those if you ever need those values. In this case, we'll go ahead and just resize this. So we're going to say my grid, and then we have to give it a width and a height. So I'm going to use those functions I just showed you to get the width and the height and add one to it. So we want to resize this, which you would use to both grow and shrink. In this case, we want to expand. So we're going to say ds grid width. So get the width of my grid and add 1 to it. Get the height of my grid and add 1 to it. And I'll see if I can expand this a little more. And that's how you use ds grid resize. So you can use it for both growing and for shrinking. So if we come in here and I say ds grid resize my grid, then you can imagine that we're going to do this exact same thing, except we're going to say -1 because we want to shrink just like that. And the last pretty interesting one that would actually be pretty difficult to replicate on your own. You definitely could, but this is one where the grid is actually really useful in my opinion, is the set disk. And I'm not covering every single function that has to do with grids or even every data structure because there's just a lot of them and visualizing some of them is a lot more tedious than it's worth. But I'm showing you the primary ones, and this one in particular is actually really interesting. So when we say set disk, we're using the function dsgrid set disk. And this sets a circular region of a grid to a certain value. So there's a lot of use cases in this that are a little untraditional. So you wouldn't use something like this for an inventory, but if you had a map or a level design where you were painting things onto it, or you were drawing out terrain, or you were marking an area like that couldn't be used because someone threw a firebomb on it or something for an enemy, like this is something you could do because it sets it for yourself. So it takes 5 things, and this is a little big. So we're going to say my grid, and I've got 2 variables already created called selected X and selected Y, and that's so that we can actually change where this function applies at. Otherwise, this is where it applies, is at those values. So the X marker and the Y marker on the grid. So we can move that around. I'm only going to do it for a radius of 2, and we're going to set it to just random values. Now, this one is really cool, so let's take a look at this. And we missed one right here, so let's add one more right there. Okay, so in grids, if I click here in the middle and I click set disk, you can see it sets all these to 1.44. This is, I think, really, really cool and very powerful because you can set how much of a size it is. All I can think about when I see this are those old school puzzles where you you hit something or you make a section blow up or change, and it changes the ones immediately around it, like in a cross area, and you have to try to light all of them up in the same color or number or whatever. This is what I think of when I see this, and so it's kind of cool. It's really powerful, and it's built in for you by GameMaker, which is pretty neat. So last thing inside of here is I want to say, well, this is the last one there. And then I want to say, if we're going to destroy this, or if we've destroyed it, then we want to create it. Then we're going to say instance create layer. And just like with the list, we're just creating the actual object itself. Okay. Let's give this grid a try and see how it works out. So, sort we've already seen. Let's try shuffle. Shuffle works. If we clear it, it's all -1. We can set the disk values there. We can grow. So in this case, it's actually growing in both dimensions, which is what we set. We can shrink it. We can destroy, and we can create. There's not a lot of error checking inside of here specifically. So yeah, if we destroyed this, we might get an error. If we create it, we might be able to create more than one. But no, actually, I think it's all good. So there we go. So that's grids. This is how they work, and that's the main functions that you have. There are more functions available if you want to check that out, but that should give you a pretty good grasp on the functionality inside of grids. So any questions there? I see some happening, so let's see if we can take a quick look at this. I see GameMaker, whoever's running that, nice work, thank you very much, is answering some questions. So why do DS lists not get garbage collected? So I am not 100% sure why. In general, data structures do function differently than just variables, which an array is simply a variable that's it's basically a list. A DS list, I think it has something to do with how it allocates memory, because you don't know how large a data structure will be, and so when you allocate that memory, you have to actually. Oh, you're fine, Cliff. It's a great question. I just don't know specifically why in GameMaker. But a data structure takes a chunk of memory, and so when you're done using it, you have to get rid of it. And if you don't, GameMaker just specifically says that it doesn't. A lot of languages do not garbage collect in general, and they do not garbage collect data structures. So if GameMaker has a much more technical answer to that, definitely post it. Otherwise, that's kind of what I know. So data structures allow for more approximation with variation, right? Let's see. Infra strategy. So I'm not quite sure what you're meaning there, Max. So if you can clarify, that would be helpful. And Rodrigo says it's a legacy thing for the garbage collection, which I imagine it is. Data structures have been around. So Rodrigo asks if I prefer data structures or arrays, and I use arrays and structs primarily. I can't think of a lot of times when I use them outside of GameMaker, like in software development in general. I've done some mobile development. I've done some software development. I went to college for CS, and like algorithms and data structures is huge there. So there are dozens of data structures outside of the ones we have available that get used. Specifically in GameMaker, no, I don't use these often in my projects. I use arrays and structs as they are a lot more versatile, especially structs these days. But having this knowledge is important, I think, because you will use it in other parts of your software development career. So, good questions. Hopefully GameMaker can find a good answer for that as well. So, again, keep asking any questions. It says it's 12:18. We started a little bit late, so I might go until 12:40, 12:45. We'll see how that goes. If you guys have any more questions, let me know. Otherwise, we're going to jump into the next data structure, which is a little more interesting because it doesn't really have as much to do with arrays and lists, kind of what we've already been doing. We're going to jump to the map. The map is really fascinating, and how a map actually works algorithmically. You can code these yourself. Like I did create maps and dictionaries, which is the formal, or I guess a different term in other places. It's called a dictionary. And you can create the algorithm yourself, and basically how you create that algorithm depends entirely on how efficient this is. There might be some difference between maps and dictionaries in like general data structure terms, but in this case, they kind of work in the same idea. So you give it a value, and then it does an algorithm to determine where that value should sit, and then it puts it there. And it can sit anywhere. And if there are multiples, they can actually kind of stack on top of each other, one after another. And that's what makes maps really unique, is you have no idea where your value is inside of a map. So you can iterate through a map. It is possible. It's not super ideal as it's quite slow. And so even visualizing this map, I've got it inside of here, but it's not the fastest thing that you can do. If this map was large and I wanted to pull a very specific value out of it and I wanted to iterate through, that would be the dumbest thing to do. There's actually specific functions to find a value because it knows where it placed it. And so when you ask for it, it can find that for you. There are ways you can iterate through a map, but again, when you use a data structure, you want to embrace what makes it that data structure. Sometimes it's frustrating, but that's where the power of it comes from. If you try to destroy it and you try to use a map just like a list, then just use a list. Don't waste your time on a map. That would just be silly. So in the create event, we create a map. I need to know the map locations to hold a 2D array. This is specifically for visualizing it. The map itself is not visualizable within GameMaker with one function. So this is all for visualizing it, cleaning up. We destroy the map, and then the draw event actually does that. So let's go to the map button, and in the create event, I'm figuring out where we're at. I created my own function inside of here, drawing the text, same thing as everything else. Now we can actually get to the fun part, which is where we actually put in the functions of a map. So let's go ahead and start on that. First thing, we have to check to make sure if it exists. So my map and ds type map. And if it does, then the text is the exact same thing. So I'll copy that and we'll say destroy being the very first one. The order of these, again, doesn't matter. So we'll destroy obj map. And I actually want this to be else ifs. So destroy is the first one. That's not unique. The next one, add. This one is a unique data structure function. So ds map add. This takes 3 arguments, the ID, the key, and the value. And this is why they're also called dictionaries, because it has a key and it has a value. So you can imagine, like, you know, imagine whatever you want. I don't really care. But it has a key and a value. So the ds map add, the ID for is the map. Now I'm going to say get map index. That's the function I created here. So it has a static variable at -1. It increases it as we go. And this is just so that I can actually access and visualize and then delete these with random values. If you were using a map regularly, you wouldn't use this. In here, you would say, like, the key would be potions or level, like it's the whatever, however you want to describe what the data is you're saving. So like if it was the position, the X position of the player, you'd say something like X position as a string, and then it would save that. And when you read it, you would put in X position and it would give you the value back. In my case, I'm doing all random numbers because otherwise I'd have to do a lot of unique functions or something inside of here. So this function just gets a number and it increases it as we go. And then I'm putting in a random number here. And hopefully that makes a little bit of sense. So we can visualize this first add one right away. If we go to maps and I go add, it adds it right there. And if I add another one, it's just drawing it somewhere randomly on the screen. They'll eventually start overlapping when there's too many of them, and that's just the visualization process. Okay. Now let's go through and power out the rest of these. So we have add, which means we also have the ability to delete. So we're going to say ds map delete. And this case, I don't know which one is which. We're just going to randomly delete one. Again, if you had specific values, this is where it would be useful. But we'll say ds map find first value. So the very first one, we'll just grab that and we will delete it. And it doesn't like that because I have to pass in my map to both of these. It has to know where it's coming from, where it's deleting it at, and then where it's finding it from. So that's how you delete something. You call ds map delete, and because of the way we're doing it, I'm defining and deleting the very first value. And as we already kind of saw right there, you can get the first and the last value. So I'm just going to do this as a show message so that we can see it. So ds map find first, or actually ds map find value. And find value is how you specifically find your value that you've done inside of there. In this case, I'll put in my map, and the key will just be the first value that we have inside of here. So find first. And I know that is slightly redundant as I am using a function that already has an answer inside of another one. Like we could have just kind of done found value and put in -1 or something, or 0. But in this case, it'll always bring me the first value here. I could have just done this, but I wanted to show you that this is also how you do that. And then if there's a first, there's also a last. So we'll do show message, ds map find value, my map, and ds map find last. That's a lot of functions inside of each other. And finally, we say else, And if my text is equal to create, we're going to make a new one because we already destroyed one. Instance create layer xy obj map. And that's where quotes are important. Okay. Let's try it out. Go to maps. So add, delete. And you'll notice that it's not deleting them in the order we put them in necessarily because I'm just grabbing the first one. So let's go to first. So the first one in here is 58. So the way it organizes it, remember, it's not a list. So if I go to first now, the first value is 733. So it changes. So you got to keep that in mind. Find first is not the first thing you put in there. It's the first thing that was algorithmically decided to be the first entry in the map, which can change over time. Same thing for last. In this case, it's 322. If I delete enough, nope, I couldn't delete enough. Looks like 322 is just the favorite number to be last, except now it's 54. Okay, then we can destroy it, then we can create it, and we can add more again. So that's a map. It's a lot different way of thinking than traditional lists, grids, and arrays, and even structs, because even structs, you know what you're putting inside of there, whereas maps, you don't. You don't know where they're at. You put it in, and then the map actually takes care of where it's at. So, does anybody have any questions on this? Someone asks, is it the same as a hash table? And yes, I do believe this is the same as a hash table. Data structures come with many different names. So as far as I'm aware, this is a hash table, a dictionary, a map, and probably a dozen other things. Being able to hash things yourselves is pretty useful, knowing how that works. I know I learned a lot having to create my own maps, so that's kind of fun. So if you got any questions, throw them out there. Otherwise, we'll continue on. Yeah, some of you guys definitely recognize the name. Maybe GameMaker, who's ever running it, can tell us why it was made as a map. Although, if I'm guessing it's been in here for a very long time, probably well over a decade or two at this point. So they might not have any clue why it's called a map. But I can tell you that it won't be changing anytime soon because it's so ingrained. Hey, Marcio, or Marcio. Awesome. I am glad to hear that. Have I ever found a use case for finding first? This webinar. That's, yeah. I can't, again, you can iterate through a map. You can find the first and last. But those functions really kind of destroy the essence of what a map and a hash table is. The whole idea is you don't think about where it goes, and it determines where it actually finds it. Like where it determines where the best place for it is. Making 2D games, I've never come across a lot of performance-heavy code where like you really, really want to find, or like where you really, really have to do something quick, and like speed is utmost important. But that's where hash tables are important. When you've got a billion entries like on Facebook, you have to be able to gather those things quickly, and that's what hash tables are good for. So in my case, no, I've used it in this webinar, and that's about it. Okay, so 12:30. I would love to go through the rest of these. So let's go ahead. And what I'm going to do is I'm just going to copy and paste the code over from each of them and kind of show you how they work, mostly because I put in a lot of time and I want you to see what it looks like. So let's just go down the list. We've done grids, list, maps. Let's go to okay. We won't go down the list. We'll hit queue next, because if we do priority queue first, that won't make any sense. So queue, create it, and this is just some data to whether we can see the head or the tail and to help make it so that they don't overlap. Queue button, let's go inside of here. So I'm going to go to my queues, and I'm just going to copy the code, and we're going to take a look at it because I think I don't want to go too far over time, even though we started a little late. I want to respect your guys' time. So let's just go through and make sure and talk about what each of these are, show you how it works, and then we'll take questions at the end. So here we are in the queue button. So if it exists, we can do all this stuff. So I will say when you start using queues, you're going to quickly realize or quickly find that phenomenon where you say a word enough and you type a word enough, it doesn't look right, because the terminology for queues is different than anything else, and this is true across the industry. You say DSQ NQ instead of add, and you say DQ instead of delete. And when you start saying Q and Q, Q and Q too much, it messes with your brain. So NQ is how you add something to it. So I'm adding a random value. DQ is how you take it off. Again, industry standard language, so GameMaker went with it, and it's good to know that. You can think of a queue data structure as a regular queue at your grocery store. Someone gets in line, you get in line behind them. When they're done, you're up next. A queue functions exactly that way. When we get to stacks, that's not the case. But a queue is actually what you would expect it to be in life. It's any queue, it's any line you've ever been in. That's how it works. So you add to it, you delete. We can get the head, and we can get the tail. We can clear, and we can destroy, and we can create it. So let's take a look. So it's empty to begin with. So if we NQ it, you can see where the tail and head is at. And we can view the tail, and we can view the head. And what's interesting about a queue is you can't see the things inside. And that's how it works. If you want to be able to see the things inside, you're not using a queue. You're using something else. So again, the use case scenarios for data structures can sometimes be pretty small, but when you need it, you just need it. So we can view the head and the tail. We can clear this. We can DQ it. We can destroy it and create it, and so on and so forth. And that's exactly how it works. Okay, didn't like that. So let's go to priority queue, as this one is a little bit different. So creating it, DS priority create. They thankfully did not call it a priority queue because that would be way too much to type, so it's just called DS priority. Cleaning up, DS priority destroy, and visualizing it is inside of here. So this one is laid out a little differently. So we have a bunch of items over here that we are going to add to the queue, or to the priority queue, and then we can change the priority of those items and then watch how it actually affects the queue itself. So let's go to the PQ button. And there's other stuff inside of here, things to like choose the sprite that we have, and being able to change pick a number. So all of this stuff I'll show you in action, as it makes a lot more sense there. But to visualize a priority queue like this, it takes a lot of extra code. So let's go in here. Now, there's actually not that much when it comes to a priority queue. You've got a priority delete max, a priority delete minimum, and then we kind of create and destroy. I actually don't think there's a whole lot, like there's more functions than that. Like you can get the size and you can change priority of specific items. This is one that I found to just be really difficult to visualize. So this is what I did for it here. And I'm looking at the queue puns in the chat. Spot on. Okay, so priority queue. Here's the items we have. They're randomized. And then here's all the items we could have. So if we add number 2 and we add number 4 and I add a 5 in between, you can see it sorts it automatically. So if I add a 1, that is now the very first item, 5 is the last. If I click on this and then I type 9, it becomes the highest priority item in the list, and this is now the lowest priority item. And so this can grow and shrink And what's interesting here is the one I added is still 1, which is why that's happening. So it can be a little, this can be a little finicky here. But the idea here is that when you change this up, the priority queue actually changes where it's at. It's automatically sorted by priority. That priority is a number which you could assign however you please, but that's what a priority queue is. You can't see the stuff in the middle, just like a queue, and all it does is you can delete things as you go, but that's about it. And I don't have any more items over here. They actually delete themselves over time. So if I left and came back, then we'd have some more items. But yeah, that's kind of how it works. You choose the priority for the item, the queue sorts it automatically. Pretty useful, and that's kind of how it works. So, and last is the stack. The stack is actually probably one of the most used data structures. Like, you might not realize it, but you use a stack all the time. I believe most Control Z and redo are stacks, because all you need to do is you need to stack it in the order that it happened. And if you want to undo something, you actually take the top one off. You don't want to go to the bottom like a queue, or the first one like a queue. You actually want the last one on there. So the way that I always think of a stack is a stack of dishes. You put things on them, and when you go to wash them, you start at the top, because you can't get to the one at the bottom until you deal with the others. Stacks also have unique terminology. So let's come over here and I'll show you what I mean. This is, again, industry-wide terminology, and they're actually putting this terminology into the latest array updates and stuff. So you'll see this kind of all over the place. So it's good to get used to this terminology of push and pop. There's also peak. There's a lot of things like that, and each one of them does something different. So the idea of a stack is you put one on top of another. So I already put this code in here, so let's visualize it with here. So when you push something, it puts it on the bottom. And when you put another one in there, it adds it to the top. So this is 90.19. The new one gets added to the top. And if we pop it, it takes that one off the top and it goes right back to where it was, just like a stack of anything, a stack of dishes. You start at the top. So when you push, it goes on the top. When you pop, it comes off the top, and you can't see the stuff below it. That's what a stack is. You don't know what's in there, but in general, you don't need to know what's in there. Again, if you want this functionality of push and pop, but to be able to see everything, I think the new functions in GameMaker actually allow you to do that with arrays, which is really cool. But you can also create that yourself, which is why, again, arrays are more versatile. But the data structures are important to understand, because if you want to replicate this functionality but add a few things into it, then you're going to want to start with a stack, and to know that the only way to interact with it is push and pop, but maybe you can view the things in there a little bit differently. I sometimes view like a stack as, you know, in an RPG game, like in a turn-based game, when you have who's going next, I kind of sometimes view that as a stack. It's probably more of a priority queue than anything else, but it's more like one of those data structures than just an array. And so having an idea of how each one of these data structures works is really useful, because you might want to do something just like this and maybe make a tweak or two. So you're taking the idea of a data structure and then you're using it for your purpose, which is really the best thing that you can do. So, all right, let's take some questions and then let's wrap up the webinar. So we've got lots of awesome jokes happening. Fabulous. Red Linked asked, are we going to keep the stream? It's either going to stay at, I think YouTube specifically keeps the stream. I don't know what GameMaker is planning on doing. I know they always do VODs, video on demand. So whether you're here or not, this will be available in the next day, week or two. With holidays happening right now, there's a lot going on. So, oh, yep. Goopreet says, yep, it's going to be saved. Perfect. All right. Well, anyone else have any questions for me? We had a good chat. I hope we learned a little bit here and there. Again, this whole project that we created together, we're going to put out as a link for you to download. Hopefully some of you will be able to find it useful and learn something from it. And if there's anything wrong with it, I guess let me know. But that's it. Cliff, you're most welcome. Thank you everyone for joining. And there you go. So, as I like to say, keep making, keep learning, and I'll talk to you later.